Hello, my name is Viraphat Pitwanakha. This video presentation is for 305.242 computer networks. In this video, we talk about Chapter 1 Introduction to Computer Networks. So in this chapter, we have 4 topics. First, overview of the Internet. Second, protocol layering. Third, Internet history. And the last is standards and administration. So let's see the definition of networks. A network is the interconnection of a set of devices capable of communication. In this definition, a device can be a host or an end system, and can also be a connecting device, such as router and a switch. So network, it has two types. First is local area networks or LANs, and second is wide area networks or WANs. And for WANs, it has two types. So first is point-to-point WANs, and second is switch WANs. LAN in the past, uh, LAN in the past, a host will connect to a cable tap. But for today, in LAN, a host will connect to a switch. A point-to-point WAN. A point-to-point WAN is a network-to-network. So a network connects to a network by connecting medium such as fiber or copper or anything. And so this is network topology types. So it has point-to-point, bus, ring, star, tree, mesh, and hybrid. So next is a switch WAN. For a switch WAN, can choose the way to go. Maybe a switch, maybe this switch can go to this switch, or maybe go to this switch. And a switch WAN used in the backbone of global communication. So this is switch, and this is connecting medium. Then an internetwork or internet made of two LANs and one WAN. So for one WAN, we use point-to-point WAN to communicate from west coast office to east coast office. And we can use point-to-point WAN and switch WAN together like this. Switching. An internet is a switch network in which a switch connects at least two links together. A switch needs to forward data from a link to another link when required. So it has circuit switch and packet switch. A circuit switch network. In a circuit switch network, a dedicated connection called a circuit, so always available between the two ends systems, the switch, making it active or inactive. So a switch can choose the phone, that what phone can be active or inactive. For the first case is fully used, and second case is one use, 1 in 4. Then a packet switch network. For a packet switch network, it has queue system. So who come first, he can use first, like this. So if this is a first, So it is a second and third and fourth, like this. The internet. The most notable internet is called the internet and is composed of thousands of interconnected networks. The internet today. For the internet today, we use backbone system. So for backbone system, it has provider network. So a provider network will let customer networks to use network. So a provider network we call internet service providers or ISP. So accessing the internet today is an internet network that allows any user to become part of it. The user, however, needs to be physically connected to an ISP or internet service provider. The physical connection is normally done through a point-to-WAN WAN. So we have using telephone networks. Then it has dial-up service and DSL or digital subscriber line. Then it has using cable networks and using wireless networks. And the last is direct connection, hardware and software. We have given the overview of the internet structure. For communication to happen, we need both hardware and software. This is similar to a complex computation in which we need both a computer and a program. In the next section, we show how this combination of hardware and software are coordinated with each other using protocol layering. Protocol layering. A protocol defines the rules that both the sender and receiver and all intermediate devices need to follow to be able to communicate effectively. A single layer protocol we can compare to just another talk to another. So we like a professor and a student in a lecture. A three-layer protocol. So for this protocol, we have three layers. So in layer 3, is listen and talk. So we got plain text that it is identical object. And in layer 2, we encrypt or decrypt. So we got ciphertext for identical object. And in layer 1, it send mail or receive mail. So mail is identical object. So we send mail or receive mail by US post. A logical connection. A logical connection is a protocol that connection between peer layers. So layer 3 to layer 3, layer 2 to layer 2, and layer 1 to layer 1. TCP/IP protocol suite. TCP/IP is a protocol suite used in the internet today, so it has 5 layers. So we will talk about layer architecture, layer in the suite, and description of each layer. So for the 5 layer, it has layer 5 application layer. Layer 4 is transport layer. Layer 3 is network layer. Layer 2 is data link layer. And layer 1 is physical layer. And we'll talk about encapsulation and decapsulation. So it has encapsulation at the source host, decapsulation and encapsulation at router, and decapsulation at the destination host. And addressing and multiplexing and demultiplexing. So layers in TCP/IP protocol suite. So for original layer, it has application, transport, internet, network interface, and hardware devices. But for TCP/IP protocol, we have application, transport, network, data link, and physical. So communication through an internet. So we start at application and then go to transport and then go to network and then go to data link and go to physical layer, then go to physical layer and go to data link and go like this. And we will start at physical layer, then go to data link, then go to network, then go to transport, and end with application layer. A logical connection between layers in TCP/IP. So the duty of the application, transport, and network layer is end-to-end, but the duty of the data link and physical layer is hop-to-hop, like this. Start from this, go to this. Start from this, go to this. And start from this, go to this. Start from this, go to this. For identical objects in the TCP/IP protocol suite. So for application layer, identical object is messages. Transport layer, it is segment or user datagram. Network, it is datagram. Data link, it is frame. Physical, it is bits. Encapsulation and decapsulation. So for encapsulation, we start at application layer. So start from this, then go to transport and go to network, data link, physical. Go like this. End at application layer from destination host. So the data start from message, use segment or user datagram, datagram, frame, bit. Addressing in TCP/IP protocol suite. Application layer, it addresses its names. Transport layer is port numbers. Network layer is logical addresses. Data link layer is link layer addresses. Physical layer has no addresses. Multiplexing and demultiplexing. For a multiplexing, we got like this. So we'll start from here, go to this and this, and end at this. But demultiplexing, we start from IP or Internet Protocol and go to TCP or UDP, and end at this, the OSI model. So for the OSI model, it has 7 layers. So in the layer 7 is application, layer 6 is presentation, layer 5 is session, layer 4 transport, layer 3 network, layer 2 data link, and layer 1 is physical. So for application, presentation, and session is application layer in TCP/IP suite. So Internet history, there were some communication networks such as telegraph and telephone networks. In 1972, Wing Cerf and Bob Kahn, both of whom were part of the core ARPANET group, collaborated on what they called the Interneting Project. They wanted to link dissimilar networks so that a host on one network could communicate with a host on another. There were many problems to overcome: diverse packet sizes, diverse interfaces, and diverse transmission rates, as well as differing reliability requirements. Internet today we witness a rapid growth both in the infrastructure and new applications. The Internet today is a set of peer networks that provide services to the whole world. What has made the Internet so popular is this invention of new applications. So it has World Wide Web, multimedia, and peer-to-peer applications. Internet standards. An Internet standard is a thoroughly tested specification that is useful to adhere to by those who work with the Internet. It is a formalized regulation that must be followed. There is a strict procedure by which a specification attains Internet standard status. The specification begins as an Internet draft. So it has maturity level. So it proposed standard, draft standard, Internet standard, historic, experimental, and informational. Then requirement levels. So it has required, recommended, elective, limited use, and not recommended. Maturity levels of an RFC or request for comment. So it it is maturity levels. So start from internet draft and then go to proposed standards. So it's processed by 6 months and 2 tries. Then it is draft standard and it processed 4 months and 2 tries. So we got internet standard and then go to history. And also internet draft is go to experimental and informational. And both of it go to history. Internet administration. The Internet, with its roots primarily in the research domain, has evolved and gained a broader user base with significant commercial activity. Various groups that coordinate Internet issues have guided this growth and development. Appendix D gives the addresses, email addresses, and telephone numbers for some of those groups. So we have ISOC or Internet Society, IAB or Internet Architecture Board, IETF or Internet Engineering Task Force, and IANA and ICAAN or Internet Assigned Numbers Authority and Internet Corporation for Assigned Names and Numbers, and Network Information Center or NIC. So it is Internet Administration. For a summary, a network is a set of devices connected by communication links. The Internet today is made up of many wide and local area networks joined by connecting devices and switching stations. Most end users who want Internet connection use the service of the Internet service providers. There are backbones ISP, regional ISP, and local ISP. A protocol is a set of rules that governs communication. In protocol layering, we need to follow two principles to provide bidirectional communication. First, each layer needs to perform two opposite tasks. Second, two objects under each layer at both sides should be identical. TCP/IP is a hierarchical protocol suite made of 5 layers: application, transport, network, data link, and physical. The history of Internet working started with APA in the mid-1960s. The birth of the Internet can be associated with the work of Cerf and Kine and the invention of a gateway to connect networks. The Internet administration has evolved with the Internet. We discussed ISOC, IAV, IATF, IRTF, ICANN, and NIC. An Internet standard is a truly tested specification. An Internet draft is a working document with no official status and a 6-month lifetime. A draft may be published as a request for comment or RFC. RFC go through maturity levels and are categorized according to their requirement level.